Hi students, in the last video we have learned about Pass1 algorithm, and in this video we are going to learn about Pass2 algorithm. Okay, so let us study. So this is nothing but in Pass2 we are going to get this kind of code. Okay, so let us see how this code is generated. Okay, so first we see the overview of the Pass1 algorithm. Okay, now uh, let us see. So first initialize means LC is initialized to 0. Okay, so after that the read, so means the next instruction will be read. Okay, so now the next the instruction will be read. So after reading the instruction it will check search for pseudo op table. Okay, so now whether this instruction is present in the pseudo op table or not, the assembler will check it. After checking, if it is found means it will check which type of pseudo op it is, whether DC, DS, using or drop. So based on that the operation will be performed. Okay, so now what is DC? Define constants means this is used to define the number or define the constant or assign the values to the particular memory location. Okay, now you can see here 4 is assigned to 4 location and 5 is assigned to the memory location 5. Okay, so now and define storage is used to allocate the storage to store some results. Okay, now you can see here st1 temp means what, whatever the result is stored in the register 1, that result is stored in the memory location temp. Okay, so that how much memory we want to store for temp symbol, that is defined using ds sudo op. Okay, now we are reserving one full memory word, okay, for the jump symbol. Okay, now after that using, why we use using, the using pseudo of is used to use the base register to store the starting address of the program or base address of the program. Okay, now why we use drop, so after ending of the program we don't want to store anything in the base register uh, 15. Now we can drop that base register. Okay, now if the sudo of is end means, see end means what, it will indicate that end of the program. After end of the program the memory will be clean up and it will be exited. Okay, now suppose if the following instruction or the LC which is pointed to the instruction is not a sudo op, means what will happen. Now if it is not sudo op, the sudo op is not found means it will search in the MOT table, it will search to the machine op table. Yes, it is a machine op means, for example, load, add, store. Okay, this all are machine ops. Okay, or machine operation instructions. Okay, now if it is found means what it will happen, so now it will take the length of that instruction and it will take what type of instruction it is, either RR instruction, RS instruction, RX instruction, SI instruction or SS instruction. So it will check which type of instruction it is, and now it will take the binary code of that. Okay, now it will take the binary code of that instructions. Okay, now, after getting that, it will evaluate the operand expression by searching for values of the symbols. Means in the past one, what happened in the symbol table and literal table are generated in the past one. Okay. Now in the symbol table, John, 4, 5, temp, these symbols are stored, and for those symbols, the LC value is assigned. The value is assigned. So now in the past two, what will happen, those values are replaced for the particular symbols. Okay, for this corresponding symbols or labels the values are replaced. Okay, now next after this assemble together the parts of the instruction. So after replacing the values of symbols, the instruction, there is nothing to get the values of any operand values, okay, any field. Now the instruction is created, okay. So after that, update the LC counter. After that, what will happen? We have to update the LC value, location counter value, okay. So after the same thing will be happen, the same steps will be repeated for the next instructions, okay. This is about the overview of the Pass1. So let us have a look into the detailed view of Pass1. Okay, this is the detailed view of the Pass1 algorithm. Okay, if you see, the same steps are repeated, but the explanation is more than the Pass1 overview. Okay, so now if you see the initialization, instead of the initialization, here they have mentioned LC is initialized to 0 clearly, and read card. In the previous overview only read is there, but they have mentioned here read card from file copy. Okay, that is the second time we are reading this assembly language program. Okay, so after reading the same thing, we the assembler is checking in the sudo op table whether the sudo op is present or what. Okay, if it is present, and which one is there, the same thing uh, will be checked here, okay, but in a detailed way. And for the machine of table also, the same thing will be done, okay. The same thing, they have mentioned here length of the instructions, the type of the instructions here clearly mentioned. If the type is RR, means register instruction type, means this process will be happened. After that, we'll get the final instruction. So punch means what here? Remember, the punch means, if you see here on the second pass the code, this line code, it is now punched. Okay, this is punched instruction now. Now after this, what does print means? What the print means, whatever the data values we are accessing for this memory location, and we are replacing those values for those symbols, that is nothing that come under print assembly listing line. Okay, so now if you see here, define constant DC in the past one, what we have done, so we have stored these values are assigned to the particular memory location, and in the second pass we are going to get these values for the respective memory locations, so that come under print assembly listing. Okay, so that's it about this detailed overview of Pass2 algorithm. If you have any doubts, put it in a comment box. Thank you.